Today we are going to start a very new topic, the name of which is spectroscopy. Through spectroscopy, we find out the structure and the environment of atoms in any molecule. It is very easy to do non-destructive testing without using any acid, base or reagent. Just by passing a few wavelengths of light and by seeing how it interacts with the molecule recorded by detector, which is computer aided, we can analyze the structure and environment of any molecule. So, as many types of wavelengths of light or electromagnetic radiations are possible, those many types of spectroscopic methods are there. So, if I have to define what spectroscopy is, I would define spectroscopy as study of interaction of electromagnetic waves with matter. We know that all the matters are made up of atoms and molecules. So, if we study the typical way or signature properties of a particular atom or a molecule with a particular wavelength of light, we will be able to find out the concentration, structure, bond length and how many atoms it is surrounded with very easily just by passing a few wavelengths of light and analyzing the transmitted light. So, spectroscopy, as I said, is a method to analyze a chemical species by passing electromagnetic radiation of suitable wavelength through it and studying its interaction with the atoms and its electrons, protons and other subatomic particles. So we have to study about each of these spectroscopic methods one by one. Now, what are these electromagnetic waves? Electromagnetic waves are the waves which come out from any oscillating charge. When electrons revolve in any orbit or when it spins, then it produces electromagnetic radiation because a spinning charge or a revolving charge will have an oscillating electric field or magnetic field around it. This oscillating electric field and the magnetic field together forms a coherent wave called as electromagnetic wave. They oscillate about each other at an angle of 90 degrees and they propagate in a forward direction, which we say as x-axis. Say if the waves of oscillating electric field oscillates in y-axis and the waves of magnetic field oscillates in z-axis or xz plane, then the direction of propagation of the wave will be towards x-axis. So these are called as electromagnetic waves. These electromagnetic waves can be of different energy, different wavelength and different frequency. As we know that the electrons can jump to higher orbit and can come down to lower orbit at a particular discrete orbit only, and it cannot come down to any other non-integral value of any integer which is not quantized. So an electron can either go to energy level 1, energy level 2, energy level 3, and there are certain permitted energy levels in which it can go, which was described well by Bohr's atomic theory, in which he said the total angular momentum of an electron remains quantized, which we can also express mathematically by saying that angular momentum mvr will be equal to n times of h by 2 pi. So, when the irradiated energy on any atom matches with the energy required for an electron to go to high energy orbit, then resonance occurs. That means the irradiated energy of electromagnetic wave and the energy absorbed by the electron or any subatomic particle to go to high energy orbit or high energy level matches. This matching of the two frequencies are called as resonance. Henceforward, when we will be using the word resonance, I would mean that the energy which is irradiated on a particular chemical species matches with the change in the energy level of any subatomic particle in the atom corresponding to that particular energy. So this is the meaning of resonance in terms of spectroscopy. Now, how many different types of spectrophotometers can be there? Since inventions and discoveries are going on, so as many different types of electromagnetic waves are there, those many types of spectrophotometers are there, like UV spectrophotometer, IR spectrophotometer, Raman spectrophotometer, microwave spectrophotometer, visible spectrophotometer, and even the spectrophotometers used in medical industry for MRI. So this MRI is also based on nuclear magnetic resonance spectroscopy. Then the X-ray which we do for our cracked bones, that is also a type of spectrophotometer only. So these spectrophotometers are the devices which produces a particular wavelength of light, according to which we have to analyze the structure of the molecule. Now, the different types of electromagnetic waves are generated by different types of material. So each of this material we will be studying subsequently when we will be discussing about the different types of spectroscopic methods, like how we produce microwave, how we produce infrared radiation, how do we produce radio waves, how do we produce UV rays, and our flow of concept or sequence of learning will be in a very fixed manner, which will help our brain to absorb the concept of spectroscopy in a very easy manner. If you go through any textbook, you would find that there are many jargons and many concepts written all together which does not have enough base in the middle year program or even in the high school. So I have made various versions of the spectroscopic topic so that anyone can understand it from ab initio. So in my next class, I will start with the topic, the name of which is microwave spectroscopy. Today, I will be leaving you with a small questionnaire or a quiz which will help you to start with this topic of spectroscopy. Thank you everyone.